Sometimes you hear these stories about incredible discoveries, ones that were basically right under our noses for decades.
Yeah.
Take Brighstoneus simmonsy. It's a brand new dinosaur species, officially named only in 2019. But the bones, they were dug up way back in 1978 after a storm on the Isle of Wight. And for years, everyone just, assumed they were more iguanodon fossils. And it's like a real-life paleontological cold case.
It really is. And it highlights how science works, how understanding evolves over time. You have this dramatic event, a storm, revealing clues, but then it takes years, maybe even generations of fresh eyes and new analysis to figure it all out.
Yeah.
What's really fascinating here is how our picture of the early Cretaceous on the Isle of Wight is getting so much richer. What we maybe once thought was just, iguanodon country is now looking like a place with several different related species living alongside each other.
Okay, so let's dig into the actual discovery first.
Yeah.
That storm back in '78 on the Isle of Wight, it caused a landslip at Grangechen, you said. So it wasn't like a planned dig. Nature just sort of shook things up and boom, fossils.
Exactly. Pure chance, really. And it wasn't professional paleontologists who found them first. It was actually the Hinwood family and a geology student, David Richards.
Ah, interesting.
Yeah. And they knew what they'd found was potentially important. They got them to the Museum of Isle of Wight Geology and the British Museum of Natural History.
It's a great reminder, isn't it, that big discoveries can often start with just observant people out and about.
Absolutely. So, okay, these bones arrive at the museums, and the first take from the paleontologist Alan Jack Chorig was that they were iguanodon, and also some bones from a meat eater, which later got named Neovenator.
That's right.
So the bones that would eventually become Brighstoneus, they were just sort of lumped in with iguanodon at first. Yes, exactly. I mean, iguanodon was the famous plant eater from that time and place, so it was the logical first guess. And then, interestingly, attention kind of shifted towards other fossils, ones thought to be Mantellosaurus, another related dinosaur. Amateur paleontologists Keith and Jenny Simmons even helped collect more bits and pieces. So the Brighstoneus material just sat there, kind of in the background, assumed to be more of the same, for a long time.
Right, until 2019. And this is where it gets really cool. A retired physician, Jeremy Lockwood, doing his PhD, he decides to take a really, really close look at all these iguanodontine fossils from the Isle of Wight. It's just amazing, isn't it? After all those years, a fresh pair of eyes, really focusing in, unlocks this secret.
It really is. And it just underscores the value of going back to museum collections, revisiting old material with new questions, maybe new techniques. Lockwood's work was meticulous. He spotted these consistent, subtle differences that just didn't quite fit with Mantellosaurus. Right. And it's kind of cool that someone coming from, outside the traditional paleontology track could bring such a rigorous approach and make this huge find. Those bones were just waiting for the right person, asking the right questions.
So in 2021, it finally gets its official name, published by Lockwood, David Mertill, and Susanna Maidment. And the name Brighstoneus, that's after the village, Brightstone, and also William Fox, an old paleontologist from the 19th century who lived there.
Mm-hmm.
And simmonsy, that's for Keith Simmons, the amateur paleontologist you mentioned. That's a nice touch, connecting it to the place and the people.
It really is. It acknowledges the whole history. Mm-hmm. And the timing is key, too. The rocks Brighstoneus came from, they're early Barremian age. That's at least 125 million years old.
Okay.
Mantellosaurus, the one it was confused with, that lived about 4 million years later. So that age gap adds more weight to them being distinct species, separate evolutionary lines.
Right, that makes sense. Okay, let's get into the nitty-gritty then. What actually made Lockwood realize this was something new? The main specimen, the holotype, is MIWG 6344. It's a partial skeleton, but crucially, it has parts of the skull and jaws. Things like the right premaxilla, some vertebrae, the sacrum, tailbones, ribs, hip bones, the thigh bone. Quite a bit to work with.
It is, yeah. It's a decent amount of material, and having skull bits is always a bonus. They often hold the really diagnostic features.
Definitely.
And it's worth remembering, these bones were found all jumbled up with those Neovenator bones you mentioned, over a pretty small area, so not like a perfectly articulated skeleton.
Okay.
Oh, and there was even evidence of beetle larvae damage on the bones before they fossilized.
Wow, really?
Yeah, gives you a tiny glimpse into the ecology back then, what happened after death.
That's wild. It also mentions a couple of vertebrae are in private hands and weren't formally described.
Yes, that's true. It happens sometimes, and it's always a bit of a shame for the complete scientific picture, but you work with what you have formally documented.
Right. So focusing on the described stuff, they identified autapomorphies. These are the unique defining features, right? The things only Brighstoneus has.
Exactly. Those are the smoking guns, paleontologically speaking.
Okay, so the first one is about the teeth. The maxillary teeth, so upper jaw, they have a main ridge on the inner side, but then also these smaller secondary ridges in front of it.
That specific structure probably tells us something about how it chewed, maybe what specific plants it specialized on. And what's really interesting is that another fossil from the Isle of Wight, IWCMS 2001.445, which hasn't been fully prepared yet, it seems to show a similar tooth pattern. So the thinking is maybe that one is also Brighstoneus. If they prepare it and confirm that, it'll give us a better idea of variation within the species.
Cool. Okay, and the second unique feature, it's the nasal bone around the nose area. It says it expands behind the nostril into a kind of swollen, bubbly shape with curved sides, like a puffy nose.
Yeah, I could even picture it like that. It's described as a swollen bulla, very distinctive shape. And these unique skull features, they often evolve for a reason. Could be related to breathing, or maybe visual display for mates, or even making sounds. We don't know for sure, but it's a key feature.
Fascinating. So those are the totally unique things, but it also has a unique combination of other traits.
That's right. Things that might be seen in other dinosaurs individually, but not together in this specific way.
Like its lower jaw, the dentary, had at least 28 tooth positions. And each spot had a working tooth and a replacement tooth ready to go underneath. Plus, the bony walls between those tooth sockets weren't parallel.
Yeah, that all points to a really efficient system for processing tough plants, constantly replacing worn teeth, having that structure. It suggests it was well adapted for grinding down vegetation, vital for a big herbivore.
And it sounds like it might have looked pretty distinctive overall. That nasal bone shape probably gave it a sort of low bump on its snout.
Probably, yeah.
And it had a noticeable crest along its back, tallest over the base of the tail. Some of those spines were huge, over 3.5 times the height of the main part of the vertebra.
That's significant, yes. A really prominent spinal crest.
Wow. You can almost picture this silhouette, can't you? That crest would have really stood out.
Absolutely. And that crest could have done a few things, maybe anchoring big muscles, maybe for display, like showing off to rivals or mates, maybe even helping regulate body temperature. It definitely would have made Brighstoneus look different from other plant eaters around at the time.
Okay, so let's place it in the grand scheme of things. Classification-wise, it's an iguanodontian, and specifically a Hadrosauriform. Can you break that down a bit? What does that tell us about its family?
Sure. So Iguanodontia is a big group of ornithopod dinosaurs, mostly herbivores. Think of Iguanodon itself, obviously. Hadrosauriforms is a subgroup within that. It includes the ancestors of the really famous duck-billed dinosaurs, the Hadrosauridae, plus their closest cousins. Now, most studies place Brighstoneus as what we call a more basal member of Hadrosauriforms, meaning it branched off relatively early in that group's evolution. Often, in the evolutionary trees, it ends up in this sort of unresolved cluster, a polytomy, with other early hadrosauriforms like Beryllium, Hypsilospinus, Iguanodon, and Mantellosaurus.
A polytomy. Like, they know they're all related, branching off around the same point, but can't quite pin down the exact order.
That's a good way to put it. Like, close cousins, but the exact branching sequence isn't totally clear yet based on the available data.
Got it. But then there's this other possibility mentioned. If you exclude a couple of characters related to the nose and hip.
Yes. In some analyses, if you tweak the data slightly specifically, excluding 2 characters from the nasal and the ilium, Brighstoneus actually pops outside of Hadrosauriforms altogether. It ends up as the sister species to Ouranosaurus.
Ouranosaurus, the one with the big sailback. That's quite a different spot of the tree.
It is, and it just shows you dinosaur relationships are constantly being tested and refined. As we find more fossils or reevaluate features or use different analytical methods, these trees can change. Sometimes small changes in the input data can lead to quite different results.
Right.
But the main takeaway is clear. Brighstoneus is definitely its own distinct thing. It's different from Iguanodon and Mantellosaurus, the other 2 hadrosauriforms we know from those same rocks on the Isle of Wight. So it tells us there was more diversity among these big herbivores in early Cretaceous Europe than we used to think.
That definitely paints a more complex, interesting picture of that ecosystem. So speaking of the ecosystem, what was the Isle of Wight actually like back then? Early Barremian period.
Well, the Wessex Formation, where the fossils came from, tells a story of a pretty warm, semi-arid climate, maybe think sort of Mediterranean-like today.
Okay, warm and maybe dryish.
Yeah, but with big rivers. The landscape was dominated by these wide, meandering river systems flowing across floodplains. And away from the rivers, on the slightly higher ground, you'd find forests. Not like modern forests, though. Think conifers, like pines, lots of ginkgos.
Ginkgos?
Yeah, ancient lineage. Plus ferns and cycads covering the ground. It would have looked quite different. Towering conifers, those fan-leaved ginkgos, and this understory of ferns and cycads.
So some lush spots near the rivers, forests elsewhere. But it sounds like a dynamic place, too. You mentioned floods earlier.
Definitely dynamic. The geology shows clear evidence of regular forest fires.
Yeah.
And fairly frequent, probably seasonal, floods. These floods would wash loads of plant debris together into big piles. And it's actually within one of these ancient plant debris beds that the Brighstoneus fossils were found.
So it's possible it died, maybe got washed into this pile of logs and leaves during a flood, and then buried quickly.
That's a very plausible scenario, yes. It would explain why the bones were disarticulated, but found relatively close together, mixed with plant matter and even those neovenator bones. It got caught up in one of these natural events.
Okay, so let's wrap this up. Brighstoneus simmonsea, a distinct Hadrosauriform dinosaur from the Isle of Wight. Its discovery story is amazing. Triggered by a storm decades ago, bones misidentified, then finally recognized thanks to the sharp eyes and hard work of a researcher revisiting the material.
That's it in a nutshell.
And it's set apart by unique features, especially in its teeth and that weirdly shaped nasal bone, plus its own special combination of other traits. It really adds another crucial piece to the puzzle of dinosaur evolution in Europe during the Early Cretaceous. Shows us more variety was happening than we knew.
Precisely. It's a fantastic example of how even places we think we know well, fossil-wise, can still surprise us. And it really speaks to the whole process of science, doesn't it? From the initial finders, maybe amateurs, to the museum curators, to the researchers asking new questions years later. It's collaborative over time.
It really is, and it gets you thinking, doesn't it? You start picturing this creature, this world, and it makes you wonder, how many other fossils are sitting in museum drawers right now, maybe with an old label on them, that are actually something completely new?
Exactly.
Just waiting for someone to take that closer look, ask that different question. It kind of highlights that paleontology is this ongoing investigation, always refining our picture of the past.
That's a perfect way to think about it. There are likely many more discoveries hiding in plain sight, just waiting for their moment. A really exciting thought.